Hi, welcome everyone to question number 10, merge to sorted linked list from the topic linked list in Geek for Geeks merge to coding questions. And before discussing the approach, please subscribe our channel. If you have any extra email IDs, please do subscribe with all those email IDs. That will be very helpful our channel to grow. And if you have any doubt, don't forget to comment below. Let's move on to the approach and let's discuss the understandability of the problem first. So let's understand the question here, then we will discuss the approach in the coding way. Okay. Coming to the approach, the question is saying there are two linked lists given. Okay. Now we have to sort this in a ascending order. How will we do that? Just you can see the output is 2, 3, 5, 10. You can roughly imagine what is happening here. So we are checking here if 2 is smaller than 5, right? If 2 is smaller than 5, so we need this variable. Okay. Then we got 2. Okay, now 2 is over. Now we have already taken 2 in the account. Now let's move on to the next value, which is 3 here. Now again we check with the other linked list is smaller or greater. It is smaller. So 3 is coming here. 3 is also done here. Now 2 is also done here. Now 20 is there. Now we are moving to the next value and we are checking again with the linked list above. Now we are seeing if 20 is smaller than 5. No, because 5 is smaller than 20. So that's why we will take this 5 value and move on to the 10 value here next. Okay, now again we compare. 10 is smaller than 20. Yes, we keep the 10 value below here. Then again we move on to the next value. 15 is smaller than 20. Yes, 15 is smaller. Then we keep 15 here. Okay, then move on to the next value here. Now we check 40 is smaller than 20 or not. No, it is not smaller. 20 is smaller here. Of 20 is smaller than 40, so we're taking 20 here. Now after that, all that, the 40 is remaining here. Okay, now if it's not only one element remaining, in other example there may be two elements remaining in the n value, or there may be elements remaining in the m linked list here. Okay, it can be in n linked list also, it can be in m linked list also. There can be values remaining. So whatever the values will be remaining, we shift our pointer to that position and we will just print out that value. Okay, now how we are linking this value? Okay, now we have to convert this into a single linked list. Okay, how will we do that? For that we have to take another pointer. Okay, a pointer for the another linked list. So for that we are going to create a dummy node. Okay, let's call it a dummy and we will store this in, this is dummy pointer. Okay, we are making a dummy pointer here and this will be very helpful. Let's understand how it is helpful. And we are storing this dummy pointer inside a variable called tail. Okay, what will this do is when we compare the cases, like let's start now. Okay, let's take m. Okay, let's name is an m variable and let's name it as n variable. And remember, m is a header which will start from 2 and n is a header which is start from 5. Okay, now let's compare now. Okay, let's compare if m is smaller than n. Okay, there are two cases. This is the first case. If m is smaller than n, what will happen? If m is smaller than n, we take the m value here and we say tail dot next. Say tail dot next. Okay, tail dot next will be equal to, what will be equal to? It will be equal to the header. Okay, header address. So header address in this case is m. And after that, now we link the first value of the m. Okay, now this value work has been done. Now we have pointed toward the value which was smaller. Okay, now we have to move on to the next value. After storing that location in another pointer, now we move on to the next value. How? We say m will be equal to m dot next. This will reinitialize and move on to the next pointer. So that next pointer will be 3 in this case. Okay, that pointer will be 3 in this case. Okay, and another case, that will be second case, that will be if and else case. This is the if case, if m is smaller than n. In else case, n will be smaller than m. Okay, this is the opposite case of the first one. So in if and else, we use these two cases. Okay, and in this case also, this is similar. This is also similar case, but the only difference is we use n value here. The tail dot next will be, the tail dot next has become n, and n is also been reinitialized by n equal to n dot next. If n value is smaller than m, okay, this is n and this is m here. You can look in this example where any value is smaller. This is n, right? So n is smaller, 5 is smaller than 20, 10 is smaller than 20, and 15 is smaller than 20. In these three cases, this value will be implemented. Okay, this will be, in these three cases, this value will be, this case will be implemented, and in another case, this case will be implemented. and all this will be implemented inside a while loop. Okay, inside the while loop till all the condition have been checked. Okay, while checking there will be one value remaining, as we discussed earlier, 40 is remaining at the end. So for that there are two conditions, that is, if head 1 is empty, right, if head 1, which is a n value here, I mean n header, if n is empty, this is empty, this is empty, then we simply say tail dot next will be equal to m. Okay, in other case that will be if m is empty. If m is empty, then only n values are remaining, there is no comparisons. Okay, there are no comparisons, only one linked list is remaining. In that case this will be the same statement will be applied. Instead of n we use n here. Okay, that's the only difference here. So this is the use of the dummy pointer. After the while loop has been completed, we simply return. Okay, we simply return the tail dot next as an output. We return this tail dot next as an output. You will have much clearer idea when we go to the coding section. I hope you have understood till this part. If it still isn't clear, watch the coding part. After that also not clear, watch the video again. Okay, let's move on to the coding part. And now we are inside the Geek for Geek website, and here is the implementation of the code. As we have discussed, we have taken a dummy variable and we have stored the linked list dummy address. Okay, that can be any address which have been stored as dummy, and that has been initialized with the tail variable here. After that, we are using a while loop, and we have used two conditions. If head 1 is none, we initialize with head 2, and if head 2 is none, then we initialize with head 1 linked list. In other case, we are comparing head 1 dot is smaller than head 2 dot or not. We are taking if else condition there. If head 1 is smaller than head 2 data, then we give the address of head 1 to the tail dot next. Okay, now tail dot next is address of head 1 in this case. In else case, tail dot next will become head 2. Okay, now we stored head tail dot next equal to this one, but we have to fix this value. Like this is a storing the value temporarily. For doing this permanent, we are using tail equal to tail dot next. Now if condition has run, then tail dot next will be stored the if condition value. If else condition value has been run, then tail dot next will be stored as header 2 value, and that will be initialized with tail variable here. Okay, after every value has been checked, if head 1 is empty, it will break out of the loop. If head 2 is empty, then it will break out of the loop. Okay, in any case, here if any case is true, it will break out of the loop after initializing the linked list whichever it is not empty. Okay, after that we're returning dummy not dot next here. So why we are returning a dummy not dot next? Okay, if you remember, dummy is equal to node 0, and this node 0 is also equal to tail. Okay, tail address and dummy address are both same at the start. Okay, now we have used tail address to link all the elements together. After linking all the elements together here, the value of tail have been changed, right? The final linked list value, okay, whatever the final linked list value is there, so that address is stored in the final tail value. So we are not using tail here, we're using dummy dot next because the address is dummy and tail are same. Now if we say dummy dot next, it automatically takes the next address, okay, which is next address of this one, this dot next. Okay, dot next of dummy, which is the starting value of the tail. Okay, which is a tail dot next, whatever the starting that we have linked to the linked list. Okay, that value will be called here using this dummy dot next. The starting tail address will be called, this dummy dot next is the starting tail address of the linked list. Okay, so this is the code. I hope you have understood. If you have still haven't understood, just give us a comment below where you're facing the problem. We'll respond as soon as possible. Now if you like the video, please do like our video and don't forget to subscribe. If you have any extra email IDs, please do subscribe with all those IDs. That will be very helpful for our channel to grow. And thank you for watching till the end. Let's meet in another question.